Okay, so I'm just going to walk you through how to take measurements of cells or other microscopic structures using an eyepiece graticule and a stage micrometer. So under the microscope, whenever you're looking at things, you'll notice you've got the scale. This is actually something that's in the eyepiece. It's called the eyepiece graticule. Unfortunately, those units don't really mean anything. So we can use that to take measurements, but we first need to calibrate them to find out what each unit on there actually represents. You'll notice that if you flick the microscope onto medium or low power, the scale doesn't actually change, and that's precisely the issue. Because if I'm looking at things at a medium or low power or high power, but we'd be taking a different measurement each time. So we need to use one of these. So I've put a stage micrometer under the microscope, and I'm just trying to move it around to line it up. So a stage micrometer is a physical slide, a piece of glass, and it basically has a very tiny ruler on it. So we can use this ruler, those are known measurements on there, and if we match them up with our eyepiece graticule, we can figure out what each unit on there actually represents. So this tiny ruler, the stage micrometer, the one I'm using here is labeled 0.01 millimeters. That's the smallest unit, and at the moment they're quite fuzzy, we can't really make them out. We're going to try and measure things under medium power, so 100 times magnification. So we're going to go on to the medium power here. If you calibrate the microscope, you have to do it under a certain magnification. If you change magnification, you have to do the calibration again. In theory, you can multiply it, but it's probably better if you just do it again. So we're going to calibrate it under medium power. So here's me trying to line up the two scales. The stage micrometer I said was labeled 0.01 millimeters. That's the distance between the smallest unit on there. The tiny little, the short lines, they're a little bit fuzzy. Between them is 0.01 millimeters. Between the larger lines, the largest lines on the stage micrometer, there's 10 of the smallest units between them, so that's 0.1 millimeters. And the entire stage micrometer, which is 10 of those larger ones, is obviously then 1 millimeter. So the smallest unit, 0.01, the next largest, there's 10 of them across there, is 0.1, and the entire thing itself is 1 millimeter. So looking at where it lines up, I'm looking for two lines that line up. I've lined up at the 0, and a little bit of a hint there. If you're trying to rotate it, it's often easier to rotate the eyepiece rather than try to actually rotate the slide, since everything's a little bit back to front when you're moving things. So just you can rotate the eyepiece is often a lot easier. Cool. So now I've lined up the 0 and the 0 on the left hand side from both our scales. So that's great. So that point's lined up. Looking for a line at the other end that lines up, and I'm looking at along the eyepiece. At about 9.6. So on the eyepiece, so the top scale, at about 9.6 I've got two lines that are lying exactly one on top of the other. So we'll write that down, 9.6 for my eyepiece. On the stage micrometer, what distance do we have there? Well, looking at that, we've got 9 of our larger units, so those are 0.1. So we've got 0.9, and then I've got another, basically 5 of the little units to the slightly shorter line would be 0.95. So the whole thing is 1 millimeter. So just coming back 5 of the smallest units to the slightly shorter, larger line is 0.95 millimeters. Fantastic. So to work out what the size of each unit on the eyepiece is, all we need to do, we take the distance on the stage micrometer that we've measured, and we're dividing it by the number of units on the eyepiece graticule at that distance. So it was our 0.95 millimeters divided by 9.6. Alright, gives us, so that means each unit on the eyepiece graticule, so from the 0 to the 1 on that top scale, is equivalent to 0.099 millimeters. Alright, so just under 0.1 millimeters. Now we can actually use the eyepiece graticule to actually measure cells. but we have to remember this is only at this magnification. Great, now we're ready to actually measure some cells. So I've taken my stage micrometer away, and I've put under a slide of some onion cells underneath the microscope now. So what we do here, first we get it into focus. Again, I'm on medium, the medium power, so 100 times magnification, because that's where we did our calibration. So I've calibrated it to 100 times magnification. And what I'm going to do now is try and line up a couple of cells with our scale. So remember, we've worked out that each unit on our Eyepiece Graticule, our scale here, is equivalent to 0.099 millimeters. So we're going to line up our cell. I've lined one up looking at the cell just in the middle underneath the scale. You'll notice that rather than rotating the slide, I found it much easier. It's actually much easier just to rotate the eyepiece. So I've just rotated that scale so it's sitting diagonally. So lining up the cell, that cell in the middle there, from the 3 to the 4, 5, 6. So that's 1, 2, 3 Eyepiece Graticule units, and it's pretty much exactly 3. Yep, exactly 3. So that would be, we would just take 3 times 0.099. So that is rounded up, basically 0.30 millimeters across. So just moving it to look at another cell now. So looking at the cell just to the left of the center underneath the scale, this one's only 2.5 units across. So we could take our value, our 0.099, and we could multiply that by 2.5 of our units, our Eyepiece Graticule units, and that would give us, rounded up, 0.25 millimeters across. So that's how we can actually measure cells. We first have to calibrate our Eyepiece Graticule, the scale that we always see that's in the eyepiece, to an actual physical distance. So we use that little miniature ruler, the stage micrometer, and once we've calibrated it, we can then use the Eyepiece Graticule, the thing in our eyepiece, to measure the actual distance of cells, as long as we're doing it at the same magnification.